Welcome to episode 3. In this video I want to go over the Esprit chassis before I start working on it. As you can see, it's been completely stripped down and cleaned up, so what better time to look at it than now. The chassis is what is commonly called a backbone structure. The body of the Esprit literally sits across the central spine like a saddle, hence the name backbone. It is the last of its kind before Lotus invented the bonded aluminium chassis for the Elise in 1996. But it served Lotus very well, this being the final evolution from the Elan chassis that was introduced way back in the 1960s. It is an exceptional structure and extremely lightweight, coming in at only 72 kilograms. Most of the construction material is folded sheet steel, commonly 16 gauge. The tubes are 1.5 inches in diameter and about 14 gauge in thickness. After welding the chassis at the factory, everything was then hot dip galvanised to protect it against corrosion, and as you can see, it has done exceedingly well. When the chassis was stripped, the first thing I did was to get it cleaned and scrubbed. I had planned to use a dry ice blaster to remove the dirt, but in the end it was quicker to do it by hand. I did this using a pressure washer and a strong degreaser, and then good old fashioned elbow grease with a lot of help from my dad. What better way to enjoy a November day than to be outside in the freezing cold scrubbing an old piece of metal? Yes, we got a lot of funny looks, but also a lot of people were very interested in what we were doing as well. After washing, a mild nylon abrasive was used to remove the stubborn dirt, and what I can only suggest is zinc oxide from the decaying galvanisation. After getting wet, I had to store it somewhere whilst it was drying, and I thought, well, what better place than my living room? So here it lived for about a month whilst I checked it over. The good news is the chassis is perfectly straight and well within Lotus's tolerances. Amazing for a car that is over 30 years old and has over 100,000 miles under its belt. Hats off to the Lotus engineers, yet again they did a superb job. Being a structures guy, whilst indoors I studied the chassis and drew the whole thing up in CAD using 3D scans, digital measuring and good old fashioned wire triangulation methods. Here is the result. This is really going to help me in designing the other components of the project, including the new cooling system, the safety cage and the modifications to the braking and suspension when they are added. It also means I can run simulated stress analysis on the structure, more on that in later episodes. Each panel is individually modelled and can be removed. This makes the CAD model an ideal way to explore the construction and gain an insight into what was one of the best chassis of its era, responsible for the Esprit's legendary handling characteristics and developed by a company that dominated Formula 1 for many years. The chassis is split up into 3 areas: the front crossmember, front suspension and supporting structure, the backbone, also known as the tunnel or the spine, and its interface panels, and the tubular steel section at the rear, which contains the engine bay and manages the rear suspension. The main front crossmember box section is made up of 2 folded pieces of 16 gauge steel capped by thicker suspension uprights. The upper suspension damping mounts are welded into place and steel tubes locate the upper and lower wishbones on both sides. 2 forward support plates are welded into place and site the lower wishbone crossmember, which is triangulated back to the main crossbeam by these square tubular sections. In later models of the chassis, these are bolt-on removable items. The steering rack mounts in true Lotus fashion act not only to support the rack but to further reinforce the front section. The front frame provides anchoring points for the radiator housing and also the front of the body shell. And finally, the pedal box mounts are situated in place. The backbone is primarily made up of a large single piece of folded sheet steel. It is formed into a large U section and it has a cutout in the top to allow the gear lever mechanism to be fitted. Inside the tunnel, the gear lever mechanism plate is welded into place, along with the seatbelt anchor point and 4 body mountings. The open section underneath is capped off by the second piece of folded sheet steel as shown. Finally, at the front, a reinforcing plate is welded at the joint to the front main cross member for added strength. At the rear, a complex folded sheet steel arrangement joins the backbone to the tubular steel section. It is completed by this second larger part welded into place. To further strengthen this section, two complex folded reinforcing plates are added on either side. Finally, this section is capped at the top with this plate, and two chassis to firewall mounts are added. The rear structure is dominated by a welded tubular construction. It has a distinctive hoop at the rear to allow the transmission to extend out of the back slightly. The bracing at the front of the bay is asymmetric to allow the engine with its offset cylinder head to fit in. The left-hand side corner is reinforced with this section. The two rear suspension trailing arms are attached to the chassis by these plates, which serve to further strengthen the tubular section. At the point where everything meets, there are two engine mounting platforms, one on the left and one on the right. The rear suspension damper mounts also serve to situate the rear suspension upper control arm, the body mounts, and the location for the removable rear cross member. The rear suspension upper control arm is further supported by these two brackets. The gearbox mounting platforms are located here and serve to brace this common point in the tubular structure. Underneath are the two rear suspension lower control arm mounts. This single side plate is where the ignition coils are mounted. And finally, here is the removable rear cross member, which can be taken off to allow the engine to be removed with the transmission. Eventually, I plan on doing a complete CAD model for the car, including the engine. Anyways, back to the real world. Before I wrap this episode up, I thought I would share some points of interest with the chassis that I discovered during my documentation. Rust around the turbo area. This is common on all 4-cylinder turbo Esprits. It is down to the extreme heat caused by the turbo damaging the galvanisation. This one isn't so bad. I've seen a lot worse where the tubular section has rusted through and needs to be patched in this area. Upside down welding. I love the little quirks on these hand-built cars. It's possibly why they are so endearing. Here, one of the body mounts is on upside down. Definitely a Friday afternoon job. I may fix it or may just make a special washer for it to counter the draft angle, but it's nothing serious. On top of the chassis is a handwritten note from 1989 where the line operator has marked the car's identity. IC stands for intercooler. R-hand obviously means right-hand drive, and 5154 is the identity for this specific vehicle. I don't know what GA means, perhaps it's someone's initials. I'm going to try and preserve this, and who knows, maybe one day I'll even add my little note to the car. Damage to the gear lever mount. Again, this is common to all Esprits, and is caused when the chassis is subject to torsion, when the car changes direction or hits a bump in the road. Cracks can clearly be seen, which highlights the stressed areas, and I will be exploring this in future episodes with computer simulations and possible solutions based upon the results. Vehicle data plate. Usually hidden by loads of dirt, but in case you were curious, the data plate on the chassis is here. Note the little tiny Lotus logo. So that is the chassis and the last of the introductions, apart from the body, which will come along at a later date. At last I can start work in earnest, so stay tuned for the next exciting episode. As always, thanks for watching.